Next part, we look at integrated rate equation. The relationship between the concentration of reactant and time is represented by the integrated rate equation. We begin with zero order reaction. In zero order reaction, the rate is constant and independent of the concentration of reactant. So if the reaction A produces products, is a zero order reaction, therefore rate equals to K A power 0. And we all know A power 0 is equals to 1. So rate is equals to rate constant or rate equals to K. We also can write in differential form negative dA over dt equals to K. The integrated rate equation for zero order therefore is A naught minus A equals to KT or A equals to A naught minus KT. A naught is the initial concentration. A is concentration at particular time. T is the time of reaction. K is the rate constant. Graphically, the zero order reaction looks like this. The first graph, rate versus concentration, you get a constant graph. From the integrated rate law, we can get two equations. A equals to A naught minus KT. We can compare with the linear equation y equals to mx plus c. So our y will be concentration of A, our x will be time t, and please take note, the gradient is negative k, it's a negative slope, while the interception at y-axis is A naught or the c is A naught. Similarly, we can draw a linear graph, A naught minus A equals to KT, and we can compare with the linear equation y equals to mx plus c. In this case, our y is A naught minus A, while our x is t. The gradient will be positive, that is k. Half-life is time taken for the concentration of reactant to reach half of its initial concentration. For zero order, half-life's formula is T half equals to A naught divided by 2K as shown in the box. The half-life of zero order reaction depends on the initial concentration of the reactant. For example, consider the reaction B produces C. The rate of reaction does not depend on the concentration of reactant. This is the statement in the question. If the rate constant is 2.95 times 10 to the power minus 2 mole per dm cube per second and the initial concentration of reactant is 4.0 mole per dm cube, determine the half-life. Now please take note, the question already mentioned the rate of reaction does not depend on the concentration of reactant, meaning this is a zero order reaction. So half-life formula for zero order is A naught divided by 2K. A naught is given in the question 4.0. 2 is from the formula. K also given in the question 2.95 times 10 to the power negative 2. Therefore, the half-life is 67.85 seconds. Unit is compulsory.